So we should be live right now, everybody. Hello again, another week, another WeAreDevelopers webinar. Program manager of WeAreDevelopers and the host of the WeAreDevelopers live session that we host every week right now. Super happy to have you here, and I'm really excited for today's webinar, not only because the topic is really interesting, but because everybody who is going to be presenting is a fellow Bulgarian. So I'm proud to be here today. Couple of house rules, as always, before we start. Please feel free to introduce yourself in the chat on the right corner. Down corner, you see the chat. Tell us where you're from. Tell us what you like to do. How do you feel already a couple of weeks or months even in quarantine? And yes, why actually you're interested in the topic. Feel free to ask questions. There is a question mark section right next to the chat. And there you can see everybody's questions and also wave and give signs if somebody needs to speak up or lower their voice down. Our presenters speakers will be taking questions throughout the whole session today. Last but not least, as always, please be kind in the comments and be inclusive. Our events, online events, also comply with with our code of conduct. So yes, let's try to all stay to respect each other. If something happens, we are here, like there are a couple of people from WeAreDevelopers who will be scouting. If you get a private comment that you feel disturbed by, or you feel that it's inappropriate, please let us know also in the comment section and we will take action. I assume most of you know WeAreDevelopers. We have 50 people pretty much already who has joined us. And but for the ones who are new to the brand and to what we do, we actually host events. Europe's leading community for developers. And we do a couple of times a year big events in Berlin and in Vienna. Well, this year it's a bit different. In Berlin, we had to cancel our event, but we're going to keep you entertained with these free webinars that we have every week. On top of this, actually, we do have a job platform that it's tailored for tech jobs, for developer jobs. So if you're looking for new opportunities or you need support in your team, please make sure you visit WeAreDevelopers.com and then you'll see, what you can do there. And yeah. As every other webinar, we're also going to have a small giveaway in December. Hopefully this will happen, so stay tuned until the end to win 2 tickets for the Vienna Congress. Now, as I'm not the star of this webinar, I would like to introduce you to our 3 speakers. I'm going to give you very brief information about what they do. And then they'll take over. They're very open, want to interact a lot. So after they give you a short introduction, everybody can participate in a discussion. Even if you want, you would be able to ask questions and you can turn on your mic, or you can keep asking the questions corner. So we have advertised actually this webinar with one speaker, and this is Boyan. He is the founder of SHYN, which is experimental quantum data visualization company. But actually, he's not alone in this, not experiment, but actually in this adventure of his. Oh yeah, it's experimental quantum data visualization. He has with him Philip and Grigory. Philip is a web developer. And also working for another company called MariaDB. And Grigory is quantum computing software engineer, if I'm not mistaken. And yep. He's been interested in quantum computing for a couple of years already. He is also very active in the field. Please give more details on your background, why you're doing this. I'll be muting myself right now. And everybody enjoy the session with the guys.
Cool. All right. Hello, everybody. First of all, thank you very much to Viljana and the whole team for inviting us today. It's a pleasure to be with you all. I know that the times are a little bit strange, so I hope that we can make use of this slightly interesting format to do something on the topic of quantum computing. It's a topic that is generating a lot of interest around the world. Hopefully, today we'll be able to do a slightly different type of discussion on the topic. My name is Boyan. I'm the founder of SHYN. We are a data visualization company for quantum computing. I'll tell you a little bit about exactly what that means later. But with me is Grigory Matein and Filip Ganchev, who are respectively the science and programming leads for the project. Not joining us today is Asya Stoimanova, who did all of the artistic design of the project. So two things to explain, first of all. Firstly, as Viljana said, we really want this to be an interactive session, and we'll find out exactly how that comes about in due course. But I'm sure that if you've joined this discussion, you're interested in quantum, and you must have read a lot about the topic, or at least something about the topic. I'm curious to hear, and we're curious to hear your thoughts, your interests on quantum, and just get a feel of the pulse of the engineering community. It's very often that I speak to business people in the space, but very rarely do I get an opportunity to speak to the engineering community and the developer community, and this is why we thought it'd be a really cool opportunity to do so. Secondly, you might have been attracted to this webinar because of the ever so slightly clickbaity title that we came up with, and I just want to off the bat say that this won't be a very highly in-depth critical look at the fundamentals of quantum computing. Very much what we're trying to do is develop some kind of practical data visualization tool or product with quantum where it is at the moment. And quantum where it is at the moment isn't where many people think it is. So I think given that, hopefully this should be a slightly different kind of discussion. So a lot of the buzz around quantum at the moment revolves around its potential to change industries such as cryptography or weather prediction or finance and so on. And there's a lot of very big claims. So when we look at creating solutions for these areas, people promise that you'll be able to break algorithms in seconds, you'll be able to predict the weather for months ahead and predict the financial markets in an instant. Realistically, though, those applications are very far away. And secondly, many of them rely on, at the moment, a lot of the interpretation is looking at quantum through a very traditional lens. So, for example, if you've looked at quantum computing, you'd have heard of qubits and so on, and a lot of the applications look to get very specific answers out of a system, which you can then use to solve traditional problems. The problem is, however, that quantum isn't that specific an area, as we will learn a little bit more. Very often, when you deal with quantum computing, you're talking about probabilities and distributions. And to us, to me, for the inspiration for this project, those probabilities give an opportunity to do something which you can't really do so easily with traditional computers, and that's to look at the idea of nuance and unpredictability in a very new way. So rather than looking to fundamentally change the world at this stage, what we're trying to do is show off the potential of quantum computing in a really easy to understand manner by anybody who's interested in the space. This involved getting a rather eclectic team together. Grigory, Filip, Asya. Asya, for example, is a theatrical stage designer, and the aim of the project was to see whether bringing this eclectic group of people together we could create a practical application of quantum computing. Now, let me give you a very short visual of what we've done before I pass over to Grigory and Philip. So I assume this was the end result of what we made. So on the face of it, a very beautiful, I think you will agree, website, which obviously, there we go, which does some stuff. It's got some lovely animations. It scrolls through. Do you not think so, Grigory and Philip? Beautiful, isn't it? I hope you think so, because you made it. So.
Indeed.
Yeah, isn't it great? Now, the website tells a very interesting story. You can all have a play with it. It tells the story about humanity's pursuit of accuracy, especially in the field of time. And we're very proud of how the website came together. But the funky thing about the site is that there is something behind the surface, below the surface, which you don't perhaps see at the beginning. And in this, I'll try and do a very smooth and actually unrehearsed segue to Grigory to give us a little bit of insight of what's actually happening behind the scenes.
Right. So I'm Grigory. Hello, everybody. I'm the quantum software guy. I'm actually currently working for Atos, and I'm getting even more and more experienced in that. So the website you saw has a few segments. So you saw the guy in the beginning, then you saw I think it was a church or a cathedral. Then you saw the watch with with the thing inside the watch and the thing which was rotating. So each one of these segments has a color, it's like a special color. In the beginning, this was the tool which the guy used. Then it was the light, so they were both orange, I remember. And then was the blue thing in the watch which was moving, right? So our idea was to have different combinations of colors. So what you saw now was one of many combinations. I think there are 16 or 32, around that number. So the whole idea is that every time you get into the website, you get a different combination, and this combination is determined quantumly, so to say. So how do we do this? Each combination of colors, let's say orange, orange, blue, which was in this case, or blue, orange, blue, for example, each such combination gets encoded into a quantum state. So if we have 10 combinations, this means 10 quantum states. And we put all those 10 quantum states together in one composite quantum state, which we measure. So between the process of producing the state and actually measuring the state, we have this quantum circuit in the middle, of course. The way we do this is starting with the circuit and with the quantum state, we send this whole packed quantum thing to an actual quantum computer. I think it's a quantum simulator, but it does the same thing. And it measures this state. So we have a superposition, as I said. I'm actually using this word for the first time, yes. But yeah, it is a superposition of all those quantum states. So we have the 10 combinations, meaning 10 quantum states, so a superposition of those 10 quantum states. And once we measure them all, so we get one state, which means one combination. And we do this many, many times, and we do get different combinations. So each one we get is completely quantumly random combination. So every time a new person comes to our website, they see the new combination which comes up from this simulator, and that's basically more or less the science and the quantum bit behind the website.
I really don't think it could have been more crystal clear than that, Grigori. That was great. Thank you very much.
Thanks.
I get the feeling that we might have a question or two more on that topic after we finish. And this is partially what I mean about the topic of quantum computing, that there's a lot of detail in there, and that's why we have Grigori here today. And if you have any questions, I hope you have questions afterwards, please do ask them, and we'll pick them up just as soon as we finish giving this overview. So after we created the quantum logic for the website, it was the task to be able to integrate that into a traditional front end that people could play with and interact with, and that task fell to Philip. So Philip, why don't you give us a few words? That was a pretty smooth segue. I think it was all right.
I would agree, yeah, for sure. Thank you, Boyan. Hello, everyone. I'm Philip, and as Boyan mentioned, it fell into my hands to do the implementation. Clearly, we cannot run a quantum computer for every visitor that we have on the website. So before I dive into more technical detail, let me just briefly introduce myself. I'm a web developer, or as I like to call it, Internet Explorer scientist. No, just kidding. My main focus is on the front end side of things, like UI and UX. Quantum computing to me is really interesting, and it's also challenging to wrap your head around it. I barely scratched the surface on the topic. And so I took SHYN as an opportunity to really learn more about it and also try to build something from scratch, test different technologies. And so with that being said, I'll just talk briefly about the implementation as well. I won't be diving too much into technical details unless if someone has questions regarding that. The website that you saw was built on top of the Vue.js framework. The main reason we chose Vue was because it's really easy to develop and iterate ideas with it. That was our main goal. All the animations, the transitions, and effects that you saw are done with CSS. And the website is divided into two scenes that we transition between by simply capturing scroll events. Now, when a visitor lands on the website itself, we do a call to a simple API that grabs the latest number from the pool of generated combinations, which is the output of the quantum model itself. After that, we render all the scenes, apply the effects based on that result. There are totally 32 states that the site can exist in, so to say. And every state is rendered on the fly. That gives us flexibility to change things rather easy. And lastly, we anonymously track and save visitor progress in a relational database for further analysis. I really wanted to show you a plot chart with that data, but at the moment the data set is way too small to be in any meaning. But basically, for every visitor, we get when he arrived at the site, basically the timestamp. We get which combination we pulled for him, and also his progress to which scene he managed to reach. Did he got bored at the first scene, or he managed to go way down into the rabbit hole, so to say. And with that being said, I'll just give the word back to Boyan.
Yeah, he or she, just to mention.
Yes, sorry.
I think after the thanks a lot for that, Philip and Grigori. I think the big question that would come up after those discussions is why? Like, why bother doing this? Why go to all of the all of the complexity and all of the detail, which on the first glance, a site which is very pretty, but why go to all of that extra complexity and all of that detail? I think for myself, I can answer that by saying that it taught me a lot. Quantum is something that I've been interested in from a physics and from a technology point of view for years. And going through this process, it showed me a lot more about the potential of the technology beyond the kind of headlines that we see on the news and read in the articles. I think the big thing that it demonstrated to me was the power of nuance. So we're used to dealing with situations where your aim in a task is to get the most accurate result, to get the most detailed picture that you can in a given situation. And I think something that I take away from this is that we face fewer and fewer situations nowadays that you can have the most accurate result. Accuracy starts to lose meaning after a certain point. And I think our experiments with what we've done show me that there's a lot more to experiment in the field of nuance and detail that we can explore. Also, another reason why was because we want to do so. We want to spark an interest in this field in a broader group of people. I loved working on this project with Grigori, Philip, and with Asya. It was great to get 4 very different people together onto a project like this, and it's giving us a lot of ideas about where to go in the future. Whilst the questions, I assume, start pouring in, Grigori, what was your so what from this project? What did you take away from it?
Well, I learned how to do a quantum program on Qiskit. Actually, I mean, there are a lot of choices to do a quantum program, but I learned how to particularly transform from the pen and paper and the student book to actually something which solves a problem.
Was it hard?
Well, oh, that question. I mean, no, it's not hard, even for someone who doesn't get anything about quantum. Honestly, guys, if you watch a few tutorials on YouTube and probably some very introductory papers, you're gonna get there in no time. I mean, the very hardcore stuff, it's just let it for the theoretical physicists and stuff. I mean, I graduated physics, but there is plenty of stuff to be developed, even on a not that deeply theoretical level. So there I am.
I guess the big challenge for many people, and something that we're kind of trying to address, is like, fair enough, you can develop stuff, but how do you develop something that's actually practical and that gives somebody some kind of value? And I think that's the big kind of challenge that's facing a lot of the industry. Philip, for you, what was the so what? Like, what did you get from this?
Well, mainly I tinkered with new tech that I hadn't the opportunity to do so. Also, it was very interesting to learn more about topic and also dive into what Grigori made and try to understand it. Unfortunately, from just looking at it, I was like, that doesn't seem familiar to me in any way. And I'm doing programming for, well, a decade now, probably. But when he actually started explaining to me, it kind of all clicked. And also to bounce back ideas of what can we do, and also experimenting with the visualization in itself was also very interesting. So yeah, pretty much.
I think as a team, the answer to that so what is that there is definitely potential to work in this, and the kind of area that we're looking at is indeed, I think I've said it 15 times already, but creating a quantum data visualization tool, which is something that we'll be working on in the coming kind of 6 months or so. And we're also looking at continuing discussions like this to be able to look into some ideas about how we could develop that and how we could go further. And I have to thank Mikhail for being the first person to ask a question. Mikhail asks, when do you guys think quantum computers are going to change conventional ones? Grigory, what do you think about that?
I mean, I was actually straight answering the question. I actually just posted the reply, and I think another person, Dražen, I'm not that well with the names, especially the international ones, but yeah, he does have a point. So quantum computers are not supposed to completely shift classical computers. They're produced for different purposes. Quantum computers, so predominantly for solving very computationally expensive tasks, like solving algorithms which are currently intractable with classical computers, but nothing like I don't know, quantum Facebook or storing images. It's mainly for the really computational part of computers, where you compute, you calculate things, and the computers are used in many industries. So it's only one tiny bit where quantum computers are gonna come in. So yeah.
Do you have anything to add to that, Philip?
Not really. I'm not that how to say qualified to give statements, but yeah, I feel the same way from what I gathered.
My impression is that for a long time to come, they're going to be working side by side in a kind of complementary, symbiotic way. Also, just to note that Dražen is a neighbor, so it's not that foreign a name. Philip asks, how do you simulate quantum devices? Random numbers?
Yeah, I can add things here. So completely quantum requires an actual device, quantum random number generator. That's I mean, it needs to be implemented with potentially with optics. That's the device I know, which is currently produced and sold, but completely quantum without a quantum device is I mean, it's just not possible. Yeah. You need random seeds from. So I'm not like the most technical guy in computer science, but you call seeds which are supposed to be random for like a very long string. The problem with that is that all those strings have an end, whereas a quantum random number generator doesn't have an end. It just gives you numbers over and over again, and the distribution is only reached in infinity. So if you toss a coin, you're only gonna get 50-50 on both heads and tails if you run the experiment infinitely many times. Whereas if you run it with those seeds, eventually, like very far in the future, but eventually you will get 50-50. So that's the main reasons. And yes, in a short answer, you need a real device.
Cool. Yeah. Daniela Kraljevic asks, what kind of problems are you planning on solving in the future? What's your next step? I'll give that one a crack, and if you want to add anything. So the first step from a kind of operational point of view showed us that the team can get together and that we can meld traditional and quantum approaches to create something that works and something that is nice. I think one of the directions that we're looking at taking this is creating something, again, visual, because I feel like there needs to be something visual in the space that people can understand, which helps to convey a greater depth of information than we're currently used to using just a traditional kind of computing approach. And we have several different avenues that we're looking at this, but again, it all revolves around that idea of giving information a little bit more depth and a little bit more nuance. Importantly, though, I think we're all aligned on the idea that we want to do something for a kind of broad audience. So we want to bring these very kind of specialized technical competences together to do something which is just as simple and easy to use as that site is. Okay. And do either of you want to add anything onto that?
Well, from my research, something that I stumbled across was it's very difficult, for me at least, it's to try to visualize those theories and the models themselves, the algorithms that are running. So for me at least, it would be pretty interesting to explore that space in a way to be able to deliver something that is easily digestible, so to say, for a broader audience that doesn't have too much deep understanding on the field itself.
Yeah.
So I think this is very interesting to explore.
I think something that I'm personally quite keen on outside of the technical side is Philip and I, what is it now, 5 or 6 years ago, worked together on a big data company that we were both part of. And the great thing about this big data space then was that there was an ecosystem around it. There was an ecosystem of all sorts of different types of developers, engineers, thinkers, business people, and so on. That doesn't exist at the moment in quantum, which for the space currently is not a great thing, but for engineers and developers and thinkers and business people is a great thing, because it provides an opportunity to begin the makings of that ecosystem. And there's a lot going on, don't get me wrong, but it's not as rich and full as many other spaces. And I'd love in some small way to contribute to making that ecosystem a little bit wider. Grigori, I love that you are simultaneously taking part in the chat conversation whilst we're going with this. That's nice.
I'm trying to cover the questions.
Don't worry about using the video for that. I mean, just go ahead and do it in the chat. That's fine. What do you think about Nisreen's question of is the quantum cryptography included to face the security and privacy risks?
The thing is, I'm not sure I fully understand the question and the direction in which it is going. So, any plan for using the quantum crypto? Oh, you mean on our platform?
Oh, I see what you mean. Yeah, not for the moment, I think is the short answer to that. Yeah.
Yep. Not on our platform. Yes.
Cool. Good. Okay. Viliana, do you have any questions or comments for us? This is nice. It feels kind of cozy because it's just the three of us on this. It's good.
Not anymore.
Not anymore. I think you're on mute, though.
I just saw Alex. Yes. Alex, I agree. By the way, seeing that there are not that many questions, maybe we can do it the other way around, actually, meaning we're thinking of doing something even more shiny, and we have been thinking of some ideas, but maybe you guys can think of something shiny as well. Like, I mean, Boyan has a better idea. Boyan,
yeah, I think so. One of the things that I really wanted to do with this discussion is to just get the discussion going around quantum in a slightly different direction, and hopefully we've begun to do that. I think it's going to be the beginning. One of the things that we're going to do, by the way, is we're going to publish the site on GitHub. Isn't that right, Philip? And yes. and we'll make it open and easy for anybody who wants to have a play around with it to do so. Anur asked what we used for the front end. Philip, if you
yeah, so we used Vue.js. I'm pretty sure quite a lot of you guys are familiar with the framework. I preach it from time to time. I think it's a really good starting point for new developers, and also, I mean, in the front end field, but also for senior ones as well. For us, it was really easy to be able to make changes and overall to develop on it. So yeah, it's built on top of the Vue.js framework with different npm packages like formatting numbers. And making HTTP requests like Axios, and all of the animations, transitions are done with CSS. And yeah, that's pretty much it.
And Grigori, could you just run us through the tools that you used on the quantum side? So Qiskit is Qiskit, so on, and the simulator that you use and everything else. Just if somebody wants to give it a go.
Sure. I think there weren't that many like different tools. So definitely Qiskit. I think the AES simulator, NumPy, the library which deals with square root arrays and so on, and basically putting those guys together. So creating a vector, which is a simple array. For example, another for loop for measuring one by one each qubit, calling some functions to figure for some specific number of combinations how many qubits we will need. So, for example, if you have 4 qubits, this means you can simulate up to, you can encode up to the power of 4, 16 combinations. So we need to figure if it's what is it, 7, 8, and 9 combinations which we want to encode, how many qubits we need. So for 7 it will be 3 qubits, for 8 it will be 3 qubits, but for 9 combinations now we are above to the power of 3, so it will be 4 qubits. Mm-hmm. And such simple functions.
And if somebody wanted to take some first steps in this tonight or tomorrow, what would be their first kind of place to look?
They need to get the big picture and then just fill the details. So the big picture would be you need a state which you measure. So then the question arises, how do you produce the state and how do you make the measurement? And the state you produce with encoding a superposition of smaller states. Then you need a circuit to evolve this state, and then at the end you need a quantum simulator to do the measurement. And then this can bow even down to what simulator you use, how many qubits you need to represent each state. So it's pretty much like a tree, like going from top to bottom.
So you would start with a clear idea of what you wanted to achieve at the end, and then kind of work down to the practicalities of it.
Yeah, absolutely. You there is this saying, I don't remember which book it was from. You need to start from the end. So you need to know what you need to achieve, what you want to achieve, and then start putting it into pieces and pieces, and then deal with each piece separately. Mm. So yeah, know what you want to do, and in this case it will be measuring a superposition. That's it. If I have to say it with measuring a superposition with 3 words, that will be measuring a superposition.
Perfect. And Daniela, by the way, I like the term pop quantum computing. It's nice, it's sweet. Philip, yeah, just on that, was it difficult because you hadn't really looked at quantum before we started digging into this project in any kind of big detail. Was it difficult taking the stuff from Grigori and understanding how to integrate that, or was it a simple process?
Simple, not really. So what Grigori sent me for his model was like probably 20 or 30 lines of code, correct me if I'm wrong. And I stared at them like probably for a good an hour. Yeah, probably an hour, yeah, without actually understanding what the hell is happening. But I was missing huge chunks of the underlying theories, right? So yeah, I was a bit lost. But when Grigori started to explain, the pieces start falling into, and also from expanding my knowledge on the field itself. So yeah, it was difficult for sure. That's
but still
why.
something that you could kind of read up on and build up an understanding of.
Yeah, and I think it's best to, as Grigori mentioned, to separate it on pieces and deal with them linearly instead of trying to figure the whole thing out. Yeah.
Cool. Grigori, what do you think about Dražen's question about how does a quantum state get encoded?
I was preparing an answer.
I bet you were. Yes, that's why I thought I'd pick it up.
I was actually thinking how to say this simply. So how do you prepare a state? You can specify the vector of the state. So what is a state? A state is so let's get a very simple example. So you have 2 qubits. This means you can represent 4 states. So 0, 0, 0, 1, 1, 0, and 1, 1, right? So each of these states has a probability, and let's say each one of them has 25% chance to being measured. So you encode 1/4, so as the probability vector. So you make this probability vector, which is just gonna be a fourth, a fourth, a fourth, a fourth, and that's how you specify your state. And then just this vector you feed into the rest of the system, and that's it pretty much.
As simple as that.
Yes, honestly, as simple as that. Yeah.
Wonderful. I think we're slowly kind of coming up towards the time that we'd kind of looked at. If there's any kind of last questions that you might have, or again, Boyan, if you wanna add anything. Oh, we got a bunch of questions.
Oh, we do indeed.
You're still on mute, I think.
Can I quickly try to answer whatever's left?
Yeah, go ahead.
So Tomasz, if I'm pronouncing it correctly, sorry. So currently, I wouldn't say there are such dangers from actual quantum computers. So I wouldn't say you need to worry about this. But if you do, let's say, store some passwords, and someone really particularly wants to attack you with some factoring algorithm, so the Shor's algorithm, then the way to go is to implement a post-quantum cryptography protocol to save your data, to protect your data. So there is a lot of research in that area. To be honest, it's not my direction of expertise, but to wrap it up for this question, there is nothing you need to worry at the moment from. More or less.
And I can add a bit to this, because I've dealt with it quite heavily. Well, most common attacks are database injections, or trying, simply put it, trying to obtain access to the database. because well, this is where the most valuable data is stored, right? Besides the source code itself. So there are very good traditional ways of trying to protect yourself from those kind of attacks. But as Grigory said, in terms of methods that revolve around quantum, I don't think they're really a threat in terms of that. Not as of now, though.
I get the feeling that we're still some years away before that becomes any kind of real threat. But then, if you think about like the opportunity of combining different fields like traditional computing and quantum computing with a lot of technical imagination around it, then I think the potential to do things both for good and for not so good are actually quite large. I just really don't think that we're there anywhere near there in terms of the technology at the moment.
And just to add to this a small thing, so John Preskill, I think that's how he was called, very famous scientist in the field, said that we're in the NISQ era, meaning our computers at the moment, quantum computers, are noisy and cannot solve problems which require a lot of time of computation, meaning they break after a few nanoseconds, microseconds. I mean, it's not enough time to do huge calculations. So it will take time for us to be full scale in quantum, and at the same time full scale in quantum attacks, for example. So we're definitely far from there.
Yeah, and I think it's slightly related, Philip, to your question about AI, at least. My observation is that the AI field is actually going at a steady kind of incremental speed at the moment, and we're seeing a lot of practical applications of AI which are getting more and more useful and more practical for the people that use those products and those services. And I would imagine that when quantum starts to feature in those situations, it's first of all going to enhance them before it begins to take them into a new direction or to a new level. Like I guess you have two different ways that you could look at quantum: as something that supplements and enhances traditional computing problems that we look at, and then as something which can take it to a completely different level. But I think those two scenarios have different paths ahead of them in terms of how much time we've got before we get there. If that makes sense. Hopefully it does. Good. I think. Sorry?
It does. Maybe I can. I saw one more question, which I have again been typing. So there was one on the future of quantum websites from Mikhail. I think that's how pronounced. I'm not sure.
Come on, Grigory. Mikhail. I've never been in a discussion where I can pronounce as many names, so I'm at least very happy.
Okay, all right. So Mikhail, so that's an interesting question. Not a thing I have thought about, at least recently, but now that you made me think about it, so I would say definitely giving access to actual quantum computers for calculations, much more powerful calculations, and that's to my understanding where the huge power of quantum computers come. Basically solving something but much faster, and the problem can be much bigger. So you have your problem, you don't have a computer to solve it, but there will be those, I don't know, 1, 10, 100 quantum computers in the world which will be very, very fast, and you send your problem there, and you get your answer back. And something very cool, which I think is being worked on at the moment with the quantum internet. Basically, imagine you're trying to come up with a new material, something very, very special. Imagine you're doing some device which needs a very special material, and if others know this material, they can steal it from you. So Another thing you can do with all this quantum internet and websites, as you suggested, is you can send for computation something without the quantum computer knowing what it is calculated, what it is computing, and nobody can steal your idea. So that's, I can see a major application of quantum websites, let's say.
And can I add to that? Sorry,
Yeah.
For me, and correct me if I'm wrong, but to me, it is very interesting to try and dive deep into this, meaning that as a challenge when building a website is usability, right? How can you make your website more accessible, more easy to use, and in turn give you more retention, make your users happy, and so on. And I think it's a huge opportunity for quantum computing to be able to quickly iterate over vast majority of different states of those websites. So, for example, let's say layouts. We can generate billions, perhaps, of possible states for this website and try to figure out which one would be ideal for our users.
Yeah.
That's
After
nice,
two such quite concrete and good answers, I don't want to add too abstract of an answer, but I think the kind of challenges that we don't live in a world that's becoming simpler and simpler, and I think that the challenges that we face and the problems that our solutions have to solve are complex ones, and by their nature they require complex solutions. So I think quantum computing fits in to that kind of growing complexity in the world, and just gives us a potential tool set to be able to address the kinds of challenges that we're increasingly trying to face. Jan asks, which one is your favorite quantum key distribution protocol? I don't know what that question means. Grigori, go
ahead. Well, I wouldn't say I know them all. I think there are quite a few. I know quite a few as well. Which is my favorite one? So I recently read and did some things with the COW. So how is it? Coherent one-way protocol. So I very much like that protocol compared to all the others because it's unique. Because so from the perspective that other protocols either need a polarization of photons, or so that was for BB84. Maybe checking how good the superposition is of a photon between the two polarization states, so horizontal and vertical. This protocol, however, it only measures the time when a photon is arrived. So completely different idea. It
Why
all
is that
starts.
good?
Yeah, well, it is good. It's nice because it gives another perspective. So this protocol is particularly good because it doesn't suffer from attenuation of the signal, which happens with all protocols which use polarization of light. So if you encode 0 and 1 in a vertical and horizontal polarization, and you transfer this photon a lot of kilometers, eventually you're going to lose information. But if the information is encoded in whether you receive a photon or not,
it's irrelevant.
Yeah, exactly. It's much more handy. So I would say cow. Yeah.
Cool. Good. We got an answer there. Philip, do you have a favorite quantum key distribution protocol?
No, unfortunately, I do not. As of now, though, maybe I will at some point.
Cool. Okay. Any last question from anyone? before we wrap up. This has been really cool, and thank you everybody for all the questions. I wasn't actually expecting it to turn into such a nice discussion. It's a tough topic, and it's great to have a group of people that we can talk to that we can get stuck into. And it's been such a pleasure to do this with you two, Grigori and Philip. It's been really cool to have these different aspects of it. I can imagine. You know, if it was just the business side, it really wouldn't give that much value to this kind of audience as well.